This is a right angle triangle, okay? So we have been given the perimeter, which is 120, and then we've been given the length of AC, which is 51. Note, the triangle is a right angle triangle, and we have been asked to find the area. Because it is a right angle triangle, we can apply the Pythagorean theorem, okay? So let's simplify the perimeter first. Now, P has been given as 120, okay? Now we know that P is equivalent to, okay, 120 is equivalent to the length of AB squared plus the length of BC squared, okay? BC squared plus the length of, okay, AC squared. All right, now let's represent AB and BC with variables. Okay, so we say let the length of AB be A and the length of AB, okay, BC be B. Okay, so our equation becomes 120 equals A plus B plus, now AC has been given as 51. Okay, so you have A squared, B squared. All right. Okay. All right, so we are going to have, this is the perimeter, so this one's all right. So this one also. All right, so you're going to have 120 minus 51 equals A plus B. Okay, so 120 minus 51 gives us 69. So you have 69 equals A plus B. So A plus B equals 69. Let's call this equation 1, okay? Now, this, we had A plus B from the perimeter. Now we are going to derive another equation using the Pythagorean theorem. Now the Pythagorean theorem says that the length, okay, the length of AB squared plus the length of BC squared should give us the length of AC squared. Now we have denoted AB, okay, or we've represented AB with A. Okay, so we have A squared, and then we have represented BC with B, so we have B squared. So A squared plus B squared equals, okay, AC is 51, so equals 51 squared. All right, so our equation becomes, so you say A squared plus B squared equals 51 squared. And let's call this equation 2. Now, from equation 1, okay, A plus B is 69. Okay, now let's square this side and square this side so that we can use the square of a binomial formula. Okay, so that we can use that same concept, or we can use the values we have in equation 2. All right, so when we simplify using the square of a binomial, we are going to have A squared plus 2AB plus B squared equals 69 squared. All right, so let's make A squared plus B squared the subject of this equation. So A squared, okay, A squared plus B squared equals 69 squared minus 2AB. Let's call this equation 3, okay? So we are going to put equation 2 into equation 3, okay? So we say from equation 2, A squared plus B squared is, okay, equals, okay, 51 squared. 51 squared, okay? So our equation is going to be, okay, we are going to put equation 2 into equation 3. So where we see A squared plus B squared, we put 51 squared. So we are going to have 51 squared, okay, equals 69 squared minus 2AB. All right, so we are going to have 51 squared minus 69 squared equals minus 2ab. All right, so let's transpose all the terms. So we're going to have 2ab equals 69 squared minus 51 squared. Now, let's apply difference of two squares at the right side of the equation. So we know that if you have x squared minus y squared, this equals x plus y multiplying x minus y. Okay, so our equation is going to be 2 multiplying ab, or 2 times ab equals 69 plus 51, okay, multiplying 69 minus 51. So we're going to have 2ab equals, now this one gives us 120, okay, and this one gives us 18. All right, so you're going to have 2ab equals, all right, so you're going to have, okay, equals 120 times 18. Now let's divide here by 2 and then divide here by 2. So this cancels this. So you have 2 goes here 1, goes here 9. Okay, goes here 9. So you have AB equals 120 times 9. Okay, so 120 times 9. So 120 times 9. Okay, so that gives us 1080. So AB equals 1080. And let's call this equation 4. Now from equation 1, okay, okay, A plus B has been given as 69. Now let's verify, okay. So we are going to put equation 1 into equation 4. Okay, but before we do that, let's make B or A the subject of the relation, okay, or the equation. So B equals 69 minus A. Now let's put B equals 69 minus A into equation 4. So we are going to have, okay, we are going to have A multiplying 69 minus A equals 1080. So our equation becomes 69A minus A squared equals 1080. All right, so we're going to have A squared, okay, minus 69A plus 1080 equals 0. All right, now we are going to use the quadratic formula to simplify this. Now we know that AX squared plus BX plus C should give us 0, okay? Therefore, we can say A is equal to 1, B equals minus 69, okay, and C equals 1080. All right. Now, let's quote the quadratic formula. So B equals minus B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so our equation becomes B equals minus 1 times, okay, minus 69, okay, plus or minus, we are going to have minus 69 in a bracket squared multiplying 4 times 1 times 1080, okay, so here is 1080. All right, all over 2 times 1. All right, so our equation becomes B equals 69 plus or minus the square root of, now 69 squared, all right, so 69 squared will give us 4,761, okay, and then 4 times 1080 will give us 4,300, okay, 320 all over 2, okay? All right, so we are going to have b equals 69 plus or minus the square root of, now 4,761 or 4,761 minus 4,320 will give us 441, okay? All right, all over 2. Okay, now the square root of 441 is 21. Okay, so our equation is going to be b equals 69 plus or minus 21. Okay, all over 2. Now remember, this is a quadratic equation, so we are going to have two values for p. Sorry, two values for b. Okay, so case 1, we are going to have b equals 69, okay, over 2 plus 21 over 2, okay? All right, or we can simply do this. Let's do it this way. Case 1, we are going to have 69 plus 21 all over 2. Okay, so we are going to have b equals, okay, so this is going to give us 90 over 2. Okay, and this gives us 2 cancels itself, 1. Cancels 90, 45. So we say b1 equals 45. Okay, all right. Now let's look for b2. So we are going to have, okay, b equals 69 minus 21 all over 2. Okay, so you're going to have b equals, okay, so 9 minus 1 is 8, 6 minus 2 is 4, so you have 48 over 2. So you're going to have, now 2 cancels itself, 1 goes here, 24. So b equals 24. So we say b2 equals 24. All right, so b1, b2 equals 45, 24. All right, now that you know the value for b, which is one side of the triangle, let's look for the value of a, okay? So we say, now remember, we are looking for only one value of a and one value of b, okay? But now we have two values for b, so we can use either b1 or b2 to find the value for a, okay? So you can say from equation 1, okay, a plus b is 59, okay? All right, sorry, equals 69, equals 69, okay? Now, when b equals, okay, when b equals 45, okay, we are going to have a plus 45 equals 69. So our equation becomes a equals 69 minus 45, okay? So our equation becomes a equals, now 69 minus 45, that gives us 9 minus 5 is 4, 6 minus 4 is 2. Okay, so you have a being 24. So this is a1 being 24. Now you can use the other value for b to find a2. But remember, we are looking for a and you're looking for b. So when a is 24, b is going to be 45. Okay, and when b is 45, a is going to be 24. I hope you get it. All right, so now that we know the value for a and b, let's sketch our diagram. So now we know that from our triangle, okay, now here is 51, okay, and then we know a to be 24, okay, and then here being 45. All right, now the question said we should look for the area of the triangle. Now the area of the triangle equals half times the length of the perpendicular sides, okay? Or half times base times height. So we are going to have A equals half times the base is 45 times the height is 24. Okay, so our equation becomes, now 2 cancels itself, 1 goes here, 12. So we have A equals 1 times 45 times 12. All right, so we are going to have A equals, now 45 times 12. All right, so you're going to have, all right, so 1 times 45 times 12, that gives us 540 square units. Okay, so this is the area of the triangle.